everybody, we will begin by importing the random module, as well as the string module. Let's create a string of characters named chars. Whatever characters you would like to use for your encryption program, list them here as a string. However, this can be a lot to write. I think a better solution would be to import some constants from the string module. I'm going to include some punctuation. I will import the punctuation constant of the string module. How the heck do you spell punctuation? Okay, that's right. Plus, I will add some digits. String dot digits constant plus string dot ASCII letters. Let's take a look at our characters so far. We have one long string of characters. What if I would like to include a space, a white space? Well, there is a constant for that, but that includes things like carriage return. That's going to warp our results. Let me show you just for a demonstration. String dot white space plus all the other stuff. We have a carriage return and some other characters. I would like to avoid that, so in place of importing the white space constant from the string module, I'm going to add a space character. That's good enough. Here are all the characters I will be using this program. Feel free to add more or less. This is all one long string. I'm going to turn the string into a list, where each character is an individual element. To do that, I'm going to take our string of chars, reassign it, then typecast my string of characters as a list. Then let's print it again. Print chars. Instead of one long string, we have a list of all the characters we'll need. I am then going to create a key, which we will shuffle eventually. Key. Then to create a copy of a list, you can type the original list dot copy method. Then I will print my key. I'm going to place these lists within an F string. Chars then key. Let's see what we have. We have two identical lists, one for the original characters and the other for the key. We're going to shuffle this key. Random.shuffle, pass in our list of key. Look at that, all of the characters are now shuffled in a random order. What we'll be doing when somebody types in some text to be encrypted, we will replace every instance of one character within that string, let's say an O, then replace it with another one. Every time we run this program, this key will be reshuffled. Let's ask for some user input. This part of our program, we will do some encryption. Plain text is the original message. Plain text equals, we will accept some user input, enter a message to encrypt. Ciphertext is the name of the encrypted message. That will be an empty string. Okay, let's say a user types in a message. Enter a message to encrypt. I like pizza. It's a very important message. Every instance of a character within my plain text, I will refer to the key and replace that letter with a different one. For example, any Z's, I have two Z's in this program, will be replaced with, let's see, capital B. Every time we run this program, though, it's going to shuffle the key, so it's not going to be consistent. What we're going to be doing is iterating over every letter in our plain text. For every letter in plain text. Strings are iterable. Find the index of every letter from our plain text within our list of characters. Let's assign a variable index. Index equals, take our list of chars, use the index method. We are looking for that letter, whatever letter we're currently on. Then return an index. then refer to our key, get whatever letter is at that same index. So we will append that to our ciphertext. It's currently an empty string. Ciphertext plus equals our key at the given index. Our ciphertext should be the encrypted message now. Let's print it out. Print, I'll use an F string. Original message. Let's print our plain text. Then our encrypted message. Print our ciphertext string. Let's take a look so far. Enter a message to encrypt. I like pizza. Then here's the new encrypted message. Every instance of a character within my plain text was replaced with another. So for example, any Z's were replaced with E. I have two E's within this encrypted message. If I were to run this program again, it would likely be different. I like pizza. And here's my new encrypted message. My Z's were replaced with semicolons this time. For every letter in our plain text, get the index of each letter, then refer to the key, add the new character to our encrypted message. It's probably best for us not to display the characters and the key, so let's hide those. We will be reusing this key for decryption. Now to decrypt the message, let's copy this section of code, paste it. We are now decrypting. We will ask for some ciphertext, then reset our plain text. For every letter in our ciphertext, refer to our key, append a character to our plain text within our list chars at a given index. We will display our encrypted message, followed by the original message. Let's try it one last time. Enter a message to encrypt. I like tacos. Here's my original message, then the encrypted message. If I were to decrypt the encrypted message, it should give me my original message. I will type in these characters exactly. Hit enter. And here is my message decrypted. I like tacos. All right, everybody, so that is a substitution cipher encryption program for beginners. When I was at university, I did turn this program in for a final assignment for a cybersecurity class, and I did get an A on it, so maybe it'll help you. And well, yeah, that's an encryption program for beginners in Python. What's up, everybody? So in today's video, we're going to create a game of Hangman using Python. I thought that this would be a good mini project for us. While learning to code, it is important to create small projects as you go along. Here's one that we can make together. When creating a project, I like to declare the various variables and data structures I'll need first, followed by the functions I'll need. For this game, we will need a set of words. One of these words is going to be chosen at random. So let's create a few words. I'll add some fruit. Apple, orange, banana, coconut, and one more. Pineapple. Using the random module, let's import that. Import random. Using the random module, we will pick one of these words at random. We won't be able to see what it is, but we can guess what the word is, one letter at a time. Once we reach 6 incorrect guesses, we lose the game. Before each guess, we will display some ASCII art, which I will name as Hangman art. This will be a dictionary where each key value pair contains a tuple. So this is a dictionary of, we'll have a key, which will be a number, and a tuple. The key is going to represent the incorrect number of guesses. So we'll start at 0. We will display a tuple, which will contain some ASCII art. Then let me just copy this. For one incorrect guess, we'll display some different ASCII art. I'll just put each on a new line for readability. So we're going to go all the way up to 6. Once we hit 6 incorrect guesses, we lose the game. Each key corresponds to the number of incorrect guesses. Once we reach 6, we lose the game. Each tuple that corresponds to the incorrect number of guesses, we will display a certain image. If you would like, feel free to look in the description of this video if you would like to copy this to save you some time. Each tuple will consist of 3 rows, 3 strings. For no incorrect guesses, where incorrect guesses is 0, we will display nothing. We can't see our hangman person. For 1 incorrect guess, we will display their head. For 2 incorrect guesses, we will display their head and the main torso of their body, which we'll represent with a vertical bar. Let me copy this one. For 3 incorrect guesses, we will display their left arm, represented with the /. With 4 incorrect guesses, we will display their right arm. However, if you use a \, that's an escape sequence within a string. You have to use double backslashes to literally print a \. So with 5 incorrect guesses, we will display their left leg of the person. Then once we reach 6 incorrect guesses, we display the full person. That's when we lose the game, when we see the entire person. That's some ASCII art that we can use. So let's test it just to be sure that everything is working fine. I will print my hangman art at the key of 0 to represent no incorrect guesses. Okay, so when we display this person, we're going to have to use some sort of loop. For every, let's say, line in hangman art at index of 0 for 0 incorrect guesses, I will print each line. With no incorrect guesses, we don't display anything. That's correct. We can't see the person, and that's okay. So with 1 incorrect guess, display the dictionary where the key is 1. That displays the person's head. 2 would be the main torso of their body. 3, their left arm. 4, their right arm. 5, their left leg. And 6, their right leg. Once we see the entire person, we lose the game. So we can delete these 2 lines of code. We no longer need them. We know that our dictionary is working. I'm going to zoom out a little bit. Following our dictionary, we'll declare the various functions we'll need throughout this program. We will define a function to display man, our hangman. There will be 1 parameter, wrong guesses. And then for the time being, I'll write pass. We'll fill in this function later. When we display our man, we need to know the number of incorrect guesses to display the right image. We have a display man function and a display hint function. We will have a string of hint. Then I'll write pass for now. Our hint is going to be a list of underscore characters. For each letter that we guess right, we'll flip one of those underscores to be a letter, if that letter is correct. I'll create a function of display answer. Within this function, we will display the correct answer, either when we lose the game or win the game. And I will write pass. We will create a function of main to contain the main body of code of our program. Again, I'll write pass for now. I'll add the following if statement. If dunder name is equal to a string of dunder main. If we are running this file directly, I would like to call the main function to start the program. All right, let me zoom out. This will be the main skeletal structure of our program. Import the random module. We have our set of words. We'll be importing more from a separate file near the end of this video. We have a dictionary where the key is a number to represent the number of incorrect guesses, and a tuple to display some ASCII art. We have 4 functions: display our man, display the hint, display the answer, and the main function to contain the main body of code. Alright, let's work within our main function. Within our main function, we will create a variable of answer. What is the correct answer that we have to guess? I will access the random module, call the method of choice, then pass in our set of words. One of these words will be chosen at random. Let's test that. I will print our answer, just temporarily. We should get a random word. Apple, apple, pineapple, apple. I guess it really likes apple for some reason. There we go, we have orange. We are choosing a word at random. We no longer need this print statement. Looks like everything is working fine. Now we'll display our hint. Our hint is going to be a list of underscore characters. I need the number of underscore characters to equal the number of characters in one of these words that is chosen at random. So I could multiply my list by the length, using the length function of my answer. So let's print our hint to see what we're working with. With my selected word, we have how many underscores? 1, 2, 3, 4, 5, 6, 7. Okay, we have a different word. 1, 2, 3, 4, 5. That is probably apple. It has 5 characters. All right, so that's our hint. It's a list of underscore characters. When we guess a letter, if it's correct, we'll fill in one of the underscores with that correct character. We need to keep track of the number of wrong guesses. We'll create a variable of wrong guesses. Set that equal to be 0 when we start the game. We're going to keep track of all of the incorrect guesses that we've made. We will create a set of guessed letters. For an empty set, we'll call the set function. Normally in Python, you can't create an empty set with just a set of parentheses. We have to use the set function. Then I will create a Boolean variable of isRunning. Set that to be true. While our game is running, continue playing. Once we lose or win the game, we will switch this to be false to exit the game. We will keep this as true when we initially run this program. After we declare the variables we'll need within the main function, we'll create a loop, a while loop. While is running. We don't need to say while is running is equal to true. We don't necessarily need to create that comparison. We can just say while is running. While this is true, continue doing some code. So what would we like to do? Let's call the function of displayMan, but we have to pass in the wrong number of guesses. Call our function of displayMan, pass in our variable of wrong guesses. When we begin the game, we would like to display one of these images. Then we will display our hint. Then we'll call the function to display our hint. Pass in our hint. That was the list of underscore characters to represent the answer we have to guess. We will create a variable of guess and accept some user input. We'll prompt the user to enter a letter. Just in case a user types in a character that's uppercase, let's add the lower method to make it lowercase. So let's fill in our displayMan function. There's not a lot to write here. When we call this function, we need to display one of these images based on the wrong number of guesses, one of these keys. Within the displayMan function, we'll create a for loop. For every line in my hangman art, this dictionary, at the key of wrong guesses. This will be a number, 0 through 6. Depending on what this number is, I will print each line. Print each line of that tuple. Let's see what we're working with. We'll do a test run. So we are displaying no person. We can't see them. For testing purposes, I'm going to change wrong guesses to be 1. We're displaying their head. 2. Displays their body. 3. Displays their left arm. 4. Is their right arm. 5. Their left leg. And 6. Is their full body. That's when we lose. Now, you don't necessarily need to do this, but I'll add some text decoration before and after. I'll add just a bunch of asterisks before and after. I think that looks better, but you do you. Let's be sure to set wrong guesses back to 0. After we display our hangman, we have to display the hint. What's the clue we're trying to solve? So we will call our display hint function and pass in our list of hint. So within the display hint function, let me zoom out, I will print the following. Between each character within our hint, each underscore, we will display a space character. Strings have a built-in join method. We'll call that, then pass in our hint. For each character within our hint, join it by an empty space. So now when we do a test run, we are displaying an underscore to represent each character. Each is separated with a space. While we're here, we'll fill in the display answer function. We just have to copy this line of code from display hint, replace hint with answer. And that's all we need for the display answer function. So let me test that real quick. After displaying our hint, temporarily, I will display our answer, just to be sure that it's working. Yep, there's our hint, and there's our answer that we have to guess. Okay, let's delete this line of code. We don't want to display the answer. I was just testing it. So the user is going to be able to type in a letter to guess, such as A, for example. Once we guess a letter, if that letter is found within the hint, if it's one of these characters, we need to switch that underscore to be one of those characters. So we'll write the following if statement. If our guess is in our answer. In is a membership operator. If this letter is found within our string of answer, we're going to create a loop. We will create a loop that will iterate once for each character within the answer. But we don't know the length of the answer because Python will choose it at random. So let's say for every index, we can shorten this to I. For I in range, the length of my answer. Let's say the word is apple. The length of the word apple has 5 characters. This would return 5. For I in range 5. Then we will iterate 5 times. We'll iterate this loop once for the number of characters within my answer. We'll check during each iteration if our answer at index of I, during the first iteration, that will be 0. Then the second iteration, it will be 1, then 2, so on and so forth. Strings are iterable. If our answer at index of I is equal to our guess, if there's a match, if we guess the correct letter, then we're going to take our hint at that given index of I and set that equal to be our guess. It looks like this if statement is outside of the while loop. I'm just going to indent it by 1, so we're within it. Okay, let's do a test run. I'm going to guess the letter A. Yes, we have one A. Let's do something that's probably not in here. Q. Okay, so there were no matches. We don't end up doing anything. So what is this word probably? This should be the word orange. So let's guess O, R, N, E, G. All right, we know that it works. What if somebody types in some input that's not valid? Before checking if that guess is correct, we'll do some input validation. What if the user types in a whole word, like pizza? We want the user to only guess a single character, not many characters. we'll add the following line. If the length of our guess that we type in does not equal 1, then I will print the following message. Let's say invalid input. Then we will use the keyword of continue to skip this loop. Continue. Okay, enter a letter. I will type the word pizza. We get this message of invalid input. We skip that loop's current iteration. I will guess A. There are 2 A's. I will type banana. And again, we get invalid input. We have to guess 1 letter at a time. What if somebody types in a number, like 1? We would like to prevent that. So within this if statement, I would like to execute this code if our guess is not an alphabetical character. I can add the following. Or not take our guess, dot, use the is alpha method. If our guess is an alphabetical character, this returns true. If it's not an alphabetical character, it's false. So we are checking if this is not an alphabetical character, we execute this code. Let's try this again. I will type in 1, invalid input, 42069. Invalid input. Let's say we guess the letter A. What if we type in a letter we have already guessed? I will guess A again. If they already guessed a letter, I don't want that to count. We'll skip the current loop iteration. I'll add another if statement. If our guess is in our set of guessed letters, then I will print the following. I'll use an F string. Our guess is already guessed. Oh, one thing I'm forgetting. Once we check that our guess is not within our guess characters, we'll take our guess letters. This is a set. Add the guess. We're keeping track of the letters we have already guessed. So I will type, let's guess A. We have 1A. If I were to guess A again, we get that message of A is already guessed. And then be sure to add continue to skip the current loop iteration. All right, now going down to this if statement, if guess is in our answer. If we guess a character that's incorrect, we will take our variable of wrong guesses, increment it by 1. Wrong guesses plus equals 1. Let's do a test run. I will guess A. There is an A. What about Q? There is no Q. We display our dictionary where the key is 1. We display that ASCII art. R? Is there an R? Yes, there is an R. This is probably orange. I would like to be sure we display the entire person. I will guess some wrong characters. We know that that works. Now we need a win condition if we guess all of the correct characters and display the entire word. We'll work on that next. If there are no underscore characters, not in our hint. This will be true if there are no underscore characters in our hint. If underscores, not in hint. We'll call our function of displayMan, pass in the wrong number of guesses. Call the function of display answer. Pass in our answer. We will print the text of you win, then set our Boolean variable of is running equal to be false. Let's win this time. I already know that this word is probably pineapple. Let's guess something incorrect. There we go. We have 2 wrong guesses, but we have correctly guessed the word pineapple. You win. And we exit the program. What if we lose? I'll add the following if statement. Else if our variable of wrong guesses is greater than or equal. So the length of our hangman art is a total of 7. There's 7 total keys. But once we hit 6, we lose the game. With this else if statement, if the length of our hangman art, the length of our hangman art is going to be 7. So we are going to subtract 1 for 6, for a total of 6. Once our wrong guesses is greater than or equal to 6, that means we lose the game. We will call the displayMan function, pass in the wrong number of guesses, display what the correct answer should have been, display answer, pass in our answer. We will print you lose, then take our Boolean variable of isRunning, set that to be false. I'll guess incorrect letters. There, the word was coconut. We have 6 incorrect guesses. We display the entire hangman. The correct answer was coconut. You lose. If you would like to import a larger variety of words, we could create a separate Python file for that. So within our project folder, we will create a new Python file. I will name this Python file words list. This will be a Python file. Let's take our set of words, cut it. I'll add a note that these are words for hangman game. Words will be a set. I recommend looking online for a very large set of words that we can use. Then just copy and paste them within here. While browsing online, I found an extensive list of animals that I can use. So here are all the possible words for my game. So from my main Python file, I have to import this module of words list. From the module of words list, import words. And now I have a greater variety of words I can use. Let's run this one last time. This word has 4 letters. I'll guess the vowels. There's an A, no E, I, O. There is an O. Is it goat? Nope. T, R, boar. All right, the word was boar. You win. All right, everybody, so that is a game of hangman that we can create using Python. Hey everybody, so we have finally made it to Python object-oriented programming. This is a very important topic. In Python, an object is a bundle of related attributes and methods. Attributes are similar to variables to describe what the object has. So look around you right now. You are surrounded by different real-world objects. Next to me, I have a phone, a cup, and a book. Each of these objects can have different attributes to represent it. For example, an attribute of the phone next to me could be version number. I could set that to be 13. Is on could be another attribute. Is the phone powered on or not? That could be true or false. Or even a price. I have a cup next to me. What liquid is within the cup? In this case, coffee. What's the temperature of the cup? Is the cup empty? Is empty. Or even a book. What's the title of the book? That could be a string. How many pages does the book have? Pages could be another attribute. Now, objects also have the capability to do things. They have methods, which are functions that belong to an object. People mix up functions and methods all the time. They're technically different. Even when teaching, I tend to make that mistake, calling a method a function and a function a method. Usually people know what you're referring to, though. A method is a function that belongs within an object. What are some actions these objects can perform? With the phone, you can make a call or receive a call, turn the phone on or turn the phone off. Those could all be functions. With the cup, you could fill the cup, drink from the cup, or empty the cup. With a book, you can open the book, read the book, and close the book. An object is a bundle of related attributes and methods. They can represent real-world items. To create many objects, we'll need to utilize a class. A class is a type of blueprint used to design the structure and layout of an object. We need to design what our objects have, their attributes, and what they can do, their methods. We will create a class of car. We will create some car objects. Class car. To construct a car object, we need a special type of method called a constructor. It works similarly to a function. We will define a function of double underscore init, meaning initialize, double underscore again, and then follow this with a set of parentheses. This is our constructor method. We need this method in order to construct objects. It's a dunder method, dunder meaning double underscore. That's a future topic. I don't want you to be overloaded with information right now. All you need to know is that we need this method in order to create objects. This method behaves similar to a function. We need to set up the parameters. Self is already provided to us. Self means this object we're creating right now, this car. So what are some attributes that a car should have? A model, that could be a string, like a BMW. A year, that could be a number. A color. Let's add a boolean of for sale. Is the car for sale or not? That's true or false. To assign these attributes, we're going to access self. Self dot the name of the attribute. Self dot model equals the model we receive. These are parameters. When we receive the name of a model, we will assign it to this object. Let's do this with year. Self dot year equals year. Self dot color equals color. Self dot for sale equals for sale. This is an example of a few attributes that a car might have. A model, year, color, and if it's for sale or not, represented by a boolean. Now, to construct a car object, we need a unique name for this car. Let's just say car1. Car1 equals, take the name of the class, add a set of parentheses to invoke the constructor. We're going to do this almost exactly like a function. We have parameters set up. We need to send a matching number of arguments. Self is provided to us behind the scenes automatically. We need a model, year, color, and if it's for sale or not. So pick a car of your choosing. I'll pick my favorite car. The model will be a Mustang. For the year, I'll go with the recent year of 2024. A color, I'll pick red. Is the car for sale? I like this car, so no. I will set that to be false. Make sure false is capitalized. Let's see what happens if I attempt to print our car object of car1. What we're given is the memory address of this car object, where it's located. But I would like one of the attributes located at this memory address. Instead of printing the object itself, we're going to access one of the attributes found within this car. We will follow the name of the car with a dot. This dot, it's known as the attribute access operator. I would like the model of car1. That would give me Mustang. Let's access the year. Take the name of the car, car1, dot, the year, 2024, followed by the color, car1, dot color, red. Car1, is it for sale? We'll print that. That is false. Now let's create a second car. We're going to reuse this class to create a second car. We will create car2 equals car. We'll pass in some different arguments. A Corvette. The year will be 2025. The color will be blue. Is this car for sale? Let's say that is true. Instead of accessing car1's attributes, let's access car2's attributes. That would give us A Corvette, the year is 2025, the color is blue, for sale is set to true. Or even a third car. Car 3 equals a new car. We will pass in a string of charger. The year, 2026. The color will be yellow. Is this car for sale? Let's say that is true as well. Then I will print car 3's attributes. The model is charger. The year is 2026. The color is yellow. For sale is set to true. With classes, they can take up a lot of space. For better organization, you can place them within a new Python file. So let's cut our class, and we will create a new Python file within our project folder. File, new, Python file. The name of this Python file is going to be all lowercase, car. Then we will paste the class that we cut originally. Class car, which has a capital C. So from our main Python file, we're going to import our car file, our car module. From the name of the module, car, import the name of the class, car. Then when I run this program, nothing should change. We should still have access to all of our car objects. You could either keep your classes within your main Python file, or import them if you would like to organize things. Let's talk about methods. Methods are actions that our objects can perform. Within our class, we will define a method of drive. Self is going to be provided to us. When we invoke the drive function, let's print you drive the car. What other things can cars do? Let's stop. We will print you stop the car. Let's take car1, access the drive method. You drive the car. Car2 also has a drive method. You drive the car. Same thing with car3. You drive the car. Let's access the stop method. Car1 dot stop. Car2 dot stop. And car3.stop. These methods are identical for each car object. Instead of printing the word car, let's insert the model of the car. I will convert these print statements to F strings. Instead of the word car, let's add a placeholder. Let's add self.model. Self is referring to the object we're currently working with. Use the attribute access operator, followed by the name of the attribute. Let's also do this with the stop method. Self.model. Let's take car1, use the drive method. You drive the Mustang. Car1.stop. You drive the Mustang, you stop the Mustang. Let's do this with car2. You drive the Corvette, you stop the Corvette. Car3. You drive the Charger, you stop the Charger. Now within our F strings, let's insert the color. I'll add a placeholder, self.color. Do this with stop as well. Self.color. You drive the yellow Charger, you stop the yellow Charger. Car1. You drive the red Mustang, you stop the red Mustang. Car2. You drive the blue Corvette, you stop the blue Corvette. Let's add one last method. Let's create a method to describe our car. We'll print the details of the car. Let's print, I'll use an F string, add 3 placeholders. Let's print self.year, followed by self.color, then self.model. We'll take car1, use the describe method that we created. Describe car1. Car1
is a 2024 red Mustang. Describe car 2. Car 2 is a 2025 blue Corvette. Car 3 is a 2026 yellow Charger. Alright everybody, so those are objects in Python. An object is a bundle of related attributes. Attributes are variables that an object has. And methods. Methods are functions that belong to an object. They define what this object can do. And well everybody, that is a summary of object-oriented programming using Python.
Hey everybody, today I gotta talk about class variables in Python. Class variables are shared among all instances, meaning objects, created from a class. Instance variables are defined inside of the constructor. Class variables are defined outside of the constructor. With class variables, they allow you to share data among all objects created from the class. With instance variables, each object has their own version. With a class variable, all those objects share one variable. Here's an example. We will create a class of student. We also need a constructor. When we create a student object, this constructor is automatically going to be called, but we need to pass in some arguments. We are provided with self. Self refers to the object we're currently working with. We will set up a name parameter and an age parameter. We will assign self, the object we're currently working with, set the name attribute to equal the data for the name that we receive from this parameter. And self.age equals age. Let's construct two student objects. We will have student1 equals, then call the constructor for student. So type the name of the class, followed by a set of parentheses to invoke it. This will automatically call the constructor, but we have to pass in data for the name and the age. For the name, let's pass in SpongeBob, because basically everybody in the world knows who SpongeBob is. I don't know how old SpongeBob is, we'll say he's 30. We'll create another student object, which we will refer to as student2. We will call the constructor of our student class, pass in data for the name and age. Student2 will be Patrick. Patrick will be 35. Okay, let's make sure this works. Let's print student1's name followed by student1's age. And we should get SpongeBob and his age is 30. Let's print student2's name and student2's age. Patrick is 35. Now we'll create a class variable. Class variables are defined outside the constructor, and they are shared among all objects created from that class. Each object has their own name and age property. These are instance variables. But class variables are defined outside the constructor. Each object will share this one variable. So if we're working with students, let's say there is a class variable of class year. What is the graduating year of this class? 2024. Now, let's print student1's graduating year. Print student1 dot class year. Okay, so SpongeBob has a class year of 2024. That's when he's graduating. Let's check student2. Patrick, his age is 35. His graduating class year is 2024. Now, with class variables, you can access them through any one object, such as student1 or student2. It's good practice to access a class variable by the name of the class, rather than any object created from the class. Since we're accessing class year, we'll access this class variable by the name of the class of student. Make sure the S is capital. This helps with clarity and readability. If I was looking at this print statement, I can tell that class year is a class variable because we're accessing it directly from the class, and not any instance from this class. Without looking at this class, I can't tell if class year is an instance variable or a class variable, but if I access it via the class name,
It's more explicit. So it's good practice to access a class variable by the class name itself, and not any one instance of this class. Let's create another class variable. We'll create a class variable to keep track of how many students we have created. This class variable will be num students, meaning number of students, equals 0. So within our constructor, we can write any code that we want. This code will always be executed when we instantiate an object. I would like to take our number of students and increment it by 1 each time we construct a new student object. So instead of using self refers to the object we're currently working with. If we're constructing student 1, just imagine we're replacing self with student 1, or student 2 if we were constructing student 2. If we're going to be modifying a class variable, in place of self, we'll use the name of the class, student. Access our class of student, get the class variable of number of students, then I will increment it by 1, plus equals 1. We are constructing two student objects. I will print access our class of student, get the number of students, and print it. We're constructing two student objects. If I print the number of students that we have, it should be 2. Then, just to be sure that this is working, let's construct a third student object. Student3 equals student. This student will have a name of Squidward. Squidward's age will be 55. Now we have 3 students. And for good measure, let's construct one more. Student4 equals, we will create a new student with a name of Sandy. Sandy's age will be 27. The number of students is now 4. Just as an exercise, using an F string, let's print the student class's class year as well as the number of students. I will print, use an F string, my graduating class of, let's add a placeholder, access the class of student, then access the class year. My graduating class of 2024 has, then we need the number of students. We'll add a placeholder, access the class of student, access the number of students, has blank students. Let's see if this works. My graduating class of 2024 has 4 students. Now, if I were to change 2024 to 2025, my graduating class of 2025 has 4 students. Let's print the name of each student. These are instance variables. Student1.name. Then we need student 2, 3, and 4. My graduating class of 2025 has 4 students. SpongeBob, Patrick, Squidward, Sandy. Alright everybody, so those are class variables. Class variables are shared among all instances of a class. They are defined outside of the constructor. The benefit is that they allow you to share data among all objects created from that class. And well everybody, those are class variables in Python.
What is going on, everybody? So today I got to talk about inheritance in Python. Inheritance allows a class to inherit the attributes and methods from another class, much like how a child in real life can inherit traits from a parent. By having a class inherit attributes and methods from another class, this helps with code reusability and extensibility. In this example, we're going to create an animal class. The dog, cat, and mouse class will inherit attributes and methods from the animal class. We will create a class of animal. Then I will define the constructor. When we construct an animal object, let's pass in a name. It's not required, but it might be good for this example. We will assign the attribute of name equal to the name we receive. Let's also add an attribute of is alive. Whenever we create an animal, we will set their isAlive attribute to be true, and that is a capital T.
All animals can eat. Define eat. We will print, using an F string, add a placeholder, self.name, the name of this animal, is eating. All animals should be able to sleep. Define sleep. Print, I'll use an F string, insert self.name is sleeping. And that is all we need for the animal class. Let's define class dog. For a child class to inherit the attributes and methods from another class, after the class name that's going to inherit, we need to add an inheritance list with a set of parentheses, then list the name of the class we're inheriting from, the parent. The dog class is going to inherit all of the attributes and methods of its parent, animal. For the time being, as a placeholder, I'll add pass, just to demonstrate this. Class cat is also going to inherit from animal. And class mouse will also inherit from animal. Okay, I will collapse this for now. We'll create a dog object, dog equals dog, then pass in a name for this dog, because we have one parameter set up of name. This dog will be named Scooby, as in Scooby-Doo. Cat equals, call the cat constructor. This cat will be named Garfield. And mouse. Mouse equals mouse. Our mouse will have a name of Mickey. Even though there's nothing within this dog, cat, or mouse class, we should still have these attributes and these methods. If you inherit the animal class, you should have a name attribute, an isAlive attribute set to true, you can eat, and you can sleep. Let's print our dog's name. Dog.name. Scooby. Print dog.isAlive. Our dog is alive. That is true. Let's have our dog object use the eat method. Scooby is eating. And sleep. Dog.sleep. Scooby is sleeping. Let's replace dog with cat. The name of the cat is Garfield. Garfield is alive. Garfield is eating. Garfield is sleeping. And mouse. Replace any instance of cat with mouse. Our mouse's name is Mickey. Mickey is alive. Mickey is eating. Mickey is sleeping. Even though these children classes are empty, we're still inheriting these attributes and methods from its parent, of animal. This is convenient because you don't need to copy and paste these attributes and methods for every single class. For example, if I were to copy these attributes and methods and paste them, well, we have a lot more code to write. And as a consequence, if I need to make a change to one of these methods, I would have to do that to every single instance of this method. For example, let's replace is sleeping with is asleep. Well, now I need to find every single sleep method and change it manually. It's not too bad if you only have a few classes, but imagine if you have hundreds of classes. That's going to take a lot of work. It's a lot easier to write the code once and then reuse it, and I only need to make that change in one place, rather than make that change many times. So let's change is sleeping to is asleep, and see if that works again. Mickey is asleep. Let's replace mouse with dog. Scooby is asleep. Not only that, but with children classes, they can have their own attributes and methods that are different from one another. So dogs have all these attributes and methods, and they can speak. Let's create a speak method, and I will print a unique message for dogs. Woof. Cats will also have a speak method, but it's going to be different. Cats will meow. Then for our mouse class, they will squeak. Let's have our dog speak. Woof. Let's have our cat speak. Meow. And our mouse. Squeak. All right, everybody, so that's an introduction to inheritance. Inheritance allows a class to inherit attributes and methods from another class. Much like in real life, a child can inherit traits from a parent. These are also known as sub and superclasses, which is a topic for another day. Inheritance helps with code reusability and extensibility,